The moment sperm enters the female body, it is treated as a biological threat. The maternal immune system immediately goes on the offensive, attacking and destroying the incoming cells as if they were a viral infection. If one lucky survivor makes it to the end, the resulting embryo aggressively burrows into the uterine wall. It breaks down the tissue to create a pool of maternal blood, establishing the necessary connection to survive. But here is the strange reality. Despite this organ acting as a bloody, temporary shield during development, some modern health trends encourage mothers to encapsulate and eat it after giving birth. Surviving the journey from a single cell to a human is a violent process. To make it through, the embryo must build a temporary, custom life support machine. That machine is the placenta. It is a biological multi-tool, acting simultaneously as a bridge, a defensive shield, and a lung for the fetus. Have you ever heard of people eating their placenta? Let me know your thoughts in the comments below. Welcome to Biology and Health, mapping the complex and often brutal processes of the human body. Today, we are investigating the extreme biomechanics of human development, tracking the journey from fertilization to the delivery room. The journey starts with a grueling physical gauntlet. Sperm swim at a microscopic rate of just 1 to 4 millimeters per minute. To assist the surviving cells, the female body initiates several mechanical supports. During ovulation, the cervical mucus changes its structure to facilitate passage, while the uterus physically pumps to propel the sperm forward. Inside the fallopian tubes, tiny sweeping hairs called cilia create a rhythmic motion that physically pushes the sperm toward the egg. When the sperm reaches the egg, it faces a dense protective barrier. The egg releases a specific enzyme that digests this outer layer, allowing a single sperm to break through and complete fertilization. This is only the first hurdle. The new entity now faces a vulnerable 6 to 12-day migration down to the uterus to find a site where it can permanently attach. Once the fertilized egg, or blastocyst, arrives at the uterus, it begins the high-stakes phase of implantation. This diagram shows the cross-section of the uterine wall. The outer cells of the blastocyst merge into a single mass called the syncytial trophoblast, which actively digests and invades the uterine tissue to root itself in place. To prevent the mother's immune system from identifying it as a foreign body, the mass secretes a hormone called HCG. These chemical signals radiate outward, suppressing the maternal immune response in the immediate area. This hormone stops the menstrual cycle and is the primary cause of morning sickness. It is also the exact chemical pregnancy tests are designed to detect. Early pregnancy is not a passive event. It is an aggressive, chemically managed invasion designed to secure the fetus's survival. By week 2, spaces called lacunae form within the invasive mass. These biological pools fill with the mother's blood as the tissue is breached. As shown in this diagram, finger-like fetal roots, called chorionic villi, extend downward, submerging themselves directly into these pools of maternal blood. This is where the biological exchange happens. Oxygen and nutrients diffuse from the maternal blood into the fetal roots, while waste and carbon dioxide move in the opposite direction for elimination. This barrier is the most critical feature. It allows for the transfer of resources while ensuring the mother's and baby's blood never actually mix. These resources travel through the umbilical cord, a lifeline rich in stem cells. Meanwhile, the placenta regulates temperature and acts as a physical filter to block many toxins and pathogens. By week 12, the organ is fully functional. For the remainder of the pregnancy, the fetus is completely dependent on this custom-built filtration and support system. As labor approaches, the body produces high levels of prostaglandins. These hormones prepare the cervix for delivery by softening and thinning the tissue. Once the baby is born, the uterus continues to contract forcefully. These spasms are designed to tear the placenta away from the uterine wall. The placenta is expelled as the afterbirth. Doctors then carefully inspect the organ to ensure no tissue has been left behind. This diagram illustrates the danger of a retained placenta. If even a small fragment remains attached, it prevents the uterus from sealing off blood vessels, leading to massive hemorrhaging and life-threatening infections. While the placenta is a vital lifesaver during development, it becomes a severe medical hazard to the mother the moment the baby is delivered. This brings us to the trend of placentophagy. Supporters claim that consuming the organ improves mood, energy levels, and milk production. However, there is no scientific evidence to support any of these health claims. Consider the placenta's primary role in this diagram. It's a biological filter that traps harmful bacteria, viruses, and environmental toxins to protect the fetus. Standard preparation methods like steaming or encapsulation are insufficient to eliminate these concentrated pathogens. They remain active within the tissue. Consuming the placenta risks infecting both the mother and the breastfeeding baby. It involves voluntarily ingesting the very dangers the organ was specifically built to block. If you want to see more breakdowns of human biology, hit the subscribe button and give this video a like. To see what happens to your body when you hold in your pee for too long, click the video on your screen right now. Stay healthy.